Okay, now recording. Thank you.
Okay.
No sound.
We'll see.
Okay.
Is everything okay?
No sound.
No sound. Agu,
Yeah.
maybe you can do something like this. When you share, there is a small button you have to press saying that you share the audio too. Okay.
Oh, okay.
When you do,
Oh,
you
yeah,
do
I saw
you
it.
have to press the button to say that to share the audio.
Yeah. Now?
Arduino is revolutionizing
Is it
rainwater.
working now?
It's
Yes,
better.
now-
Yes, you can.
Okay.
You
Great.
can start at the beginning, okay? Restart, please.
Hey there, Eco Warriors. Today, I'm thrilled to share how Arduino is revolutionizing rainwater collection. We all know water scarcity is a looming crisis, right? So why let precious rainwater go to waste when we can collect and use it efficiently? That's where our smart system comes in. At the heart of this innovation is the trusty Arduino. We've hooked it up with an MHRD rain sensor that detects rain and kicks off the water collection process. If it's raining, the water level sensor checks the tank's fill level. When it's low, the system alerts you by buzzing, signaling it's time to collect. And don't worry, once the tank is full, the buzzer goes silent to save energy, but it doesn't stop there. Our system also conditions. Using an LDR sensor, it measures light levels to determine day or night. Based on this data, a servo motor moves solar panels to the optimal angle, 180 degrees for sunlight, 0 degrees for low light. How cool is that? Everything's connected via a breadboard and wires with sensor data read through Arduino's analog input pins. Real-time monitoring is a breeze thanks to the serial port. This eco-friendly system is a game changer for water management. It's automated, efficient, and adaptable to environmental conditions. Developed under the Erasmus program, it's set to make waves in sustainable agriculture, smart cities, and beyond. Let's embrace this smart solution and save our precious water resources for a better future. Catch you later, and let's keep saving the planet, one drop at a time. Hey there, Eco Warriors. Today,
Now, Abdurrahman will explain the post-production and the thinking part of the project, then I will touch on the technical parts.
Okay, as you saw at the video, we are working in a house project that uses water resources more efficiently. As a part of this project, we have implemented a solar tracking system to maximize energy efficiency. This system allows us to get more efficiency from solar.
Problem with internet.
That connection.
By
Yes.
this of as well one of the important system that senses rainfall and alerts us when the water tank is full, allowing us to use rainwater more efficient.
Would you understand? I only got some words.
Yes, the bad internet connection because of Paulo. Oh, can you explain us, please? Maybe your internet is better.
Okay, I'll try, and if
Please,
there's
thank
a
you.
problem with my connection, please warn
It's
me.
better. We can hear you.
Okay, so as you know, water management is a critical issue, and especially in regions where water scarcity is a problem, and people often forget to check their water tanks, leading to shortage. And additionally, collecting rainwater efficiency can be challenging. So to solve this problem, we design a smart water management and solar tracking system. Our system detects rain, measures water levels, and also uses a solar panel that automatically adjusts its position to follow the sunlight. All components are placed inside a house model that we built, and making it a compact and, how can I say, a practical demonstration of smart technology. So I will explain the technical details now. The system consists of a rain sensor for detects the rain intensity, and secondly, a water level sensor to monitors water level in the tank, and a buzzer for alerts the user when water is being collected, and a solar panel and with light sensors adjusts its position to follow sunlight for maximizing energy efficiency. And also we build a house model, and all components are placed inside a small house model to simulate a real-life applications. And the Arduino code reads values from both the rain and water levels when to activate the buzzer. And if it's raining and the water level is low, the buzzer turns on to indicate water collection. If the water tank is full, the buzzer turns off. Where there's no rain, the buzzer stays off, something like this. And additionally, the light sensors control the solar panel, allowing it to turn towards the strongest light source. It is for the best energy efficiency by keeping the panel in the optimal position. And the system runs in a continuous loop, updating every second, and all the sensors values are displayed in the serial monitor. Yeah. Is there any question or something?
Okay, August, thank you. So as far as I can understand, the solar systems and the water management system are independent from each other. Yes.
Yeah, they are independent.
Yeah, but they're working with each other also.
Well, in what way?
In what way? Oh, so the water level sensor is looking for how can I say water level sensor. Okay, if the water tank is full, the buzzer turns off. When there's no rain, the buzzer stays off. So the rain sensor is looking for there's a rain or not, and the water sensor is looking for the tank. And if there's a rain and tank is full, the buzzer stops. There's no voice anymore. So the sensors working with each other for seeing is there still a rain when the water tank is full or not.
Okay.
Did I explain?
Yeah. Let me say if I understand.
Yeah.
So the buzzer is making noise when the tank is not full.
Yes.
God. So we will have music all the time.
Until it rains.
Yeah.
Again, let it rain.
Should it be the opposite? Should it be the
We will dance
opposite?
together. Ara, we will dance together.
Okay. But I would say maybe on the opposite. If it's full, then the buzzer starts working. Where it is not full, the buzzer stops. I don't know. Too much music, maybe. I don't know.
Traditional music.
Yeah, okay. But what about solar system? So the movement of the panels, is it controlled by Arduino?
With the engine.
Okay, okay. Did you ever consider to use the energy from the solar panel to control it by itself?
Yeah, we think about that, but the Arduino is very limited and the energy is not much that we want.
No.
So it's working with the computer, with the computer's energy, but the solar panel also lighting up the lights of the house.
Okay.
So we want to use the solar sensor for something, and we think that's be great.
Okay. So that's the connection between the solar panel and the house, the lighthouse. Okay, great. It's a great project. I look forward to see something more about it. Unfortunately, I won't be in Rhodes this time.
Oh.
But I will look for your project very carefully.
We'll send more information about.
Yeah.
Paolo,
Great.
I have to explain something. We have
Yes.
some limitations because of the month, you know, Ramadan month, we are mostly fasting, and the students had exactly exam weeks, so they had limited time to work. So they will be working on that project. Don't worry, they will make progress, I guess.
Okay, great,
Mhm.
great. I think it's a great project.
Thanks.
Really, really. So I don't know if any one of you wants to put some question to the Turkish team. No? Okay.
We'll just have to wait and see.
Yeah. I'm afraid they have something in their hand, you know, something secret that they will show you in the mobility. Okay, so
Sure.
shall we go to another project? Let's say, for example, Latvia.
Yes,
Hello?
hello everyone. I finally fixed my camera.
Oh, yes. Hello, Julia.
Hi, nice to see you again.
Yes, nice to see you again too.
And another. So I will introduce shortly my team and then they will connect with that project what we have. So we are working today with Milana Stashonaka. Milana, say hi.
Hello, everyone.
Hello.
Glad to be here.
Thank you. And the Romance. We have Romance as well. Where is Romance? The only boy in the project.
Oh boy.
Don't worry, we are always the same.
Roma, say hi. Can you say hi? Yes. I probably cannot hear you. Something happened. Still cannot.
He's a shy boy.
I think it's something with the sound happened. Okay, then wave with hands. At least that you are here and you can hear us. Okay, then we have another Milana. Another Milana Voronina. Milana,
Hello,
please say
everyone.
hi.
Hello.
This is
Hello.
Milana. And also we have Eva.
Hi.
Eva, say hi. And Alice. Do we have Alice here? All girls. Okay, Alice probably not here. And second teacher who will be with me and kids in Rhodos is Yekaterina. She is also driving on the way. Yes, thank you. So please, Milana, put this screen share and start with the project. Thank you.
So do everyone see the presentation?
Yes.
You have to activate sound if your video has sound.
Video sound?
No, it's a presentation.
No, we have
Oh, it's a presentation. Okay,
Yes,
okay.
it's
Sorry.
no video they will.
Okay.
Sorry, I have some problems. I'm so sorry. Hello everyone. We are Latvian team and we are so excited to be here and present our project. Firstly, nowadays problems that connected with the space is more and more valuable and important nowadays. So the realm of space exploration has become an exciting frontier for innovation and discovery. And our team are so excited to help and solve some problems that connected with the space. And Roma will name the problem.
Milana,
Sure, we can
maybe,
hear Roman.
Milana, maybe you want to close the window on the right.
Yes, I can. Yeah.
There's an X on the top, and you can close it. Do you see the X on the right?
Milana, nospied šito ķeksītī, kas tev labajā pusē stāv, tad tu izslēgsi. Var izslēgt?
Yes, yes, there. Yes, there. To the yes,
So-
close it.
Mhm.
Great.
Oh.
Right. It's
Yeah,
great.
better.
It's great.
So where is Roma? Okay, so I present the idea of our project. We wanted to create a device that will help astronauts in the space. Our device will help to avoid the garbage in the space. It will switch on signals to astronauts if something will be really near to station or rocket, so it won't be any collisions to rockets. And Yeva?
In conclusion, the problem of space garbage is very vital and requires modern solutions. Our team hopes to present an effective solution to this issue, but some changes may occur during the development process, as we have not yet tried to implement idea in a program.
Thank you for the attention. I think that you have questions because our project are in progress now, and we don't try to use the program that we need to do. So we can just explain the main idea of our project. So as we said before, the aim is to help rockets in the space, to help them save them from the space garbage that are in the space. Our sensors will will do a signal when some garbage will fly in the space, and then our rocket will be redirected to another side from this garbage to save the rocket. Yes. Is the idea clear, or maybe do you have
Okay.
some another questions about the project?
Yeah, I have a question, Milana, for you and the other Latvian team. Will you build a rocket?
No, we won't build the rocket. I think we will do like a
I'm just kidding, you know. I know you want you will
Yes.
be building a
Yes.
rocket, of course. So your idea is to prepare something, or let's say a setup that will be a simulation of what the rocket could have to avoid the impact of objects in space. Yes?
Yes, definitely, yeah.
Okay. So are you using what, Arduino or Microbit for
Arduino.
Okay, so you have some sensors which will be connected to Arduino, who will detect, I don't know, I'm just thinking, but maybe they will detect the proximity of objects and will do something to either to avoid them or to make some instruction to the rocket so that the rocket goes in another direction. Is that so?
Yes, exactly, yeah.
Okay, will it be a game or not?
No, it won't be a game.
Okay, so it will be really a prototype of something, yes?
Yeah, we hope so.
You hope so. So at what stage of the project are you? At 10%, 5%, 50%?
I think like 30%.
30%.
40%.
Okay. So do you think you will get a prototype or something for the mobility?
To be honest, we don't know yet, but I think we try to make a prototype. Yes, I think so.
Okay.
Thank you.
Maybe you can stop sharing
Ah, yes, of course. I'm sorry.
Yeah, okay. So, well, that's a great idea. You know, that's one of the biggest problems of rockets is to avoid objects that fly in space.
Yeah, thank
And
you.
so that is a huge problem. Of course, you are not building a rocket, but this is a very interesting problem. Yeah, it's a very interesting problem. Okay, so does anyone want to put some question to the Latvian team?
Not a question. I will close my this connection because I want to start on my laptop. Just to announce you. Yes.
Oh, yes. Okay. So you were right
Sorry.
home. I can see.
Yes. Okay.
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 So let's proceed. Maybe now we can go to Portugal. We can come to Portugal because I'm in Portugal too. So Portuguese team, would you like to present your ideas?
Hello, we are from Portugal, and our group name is Levitugation. And I'm Catarina.
I'm Rita,
I'm Tiago. I'm Diogo.
and we are glad to be here.
Adriana is there too, but we don't know if she can talk, but she is part of our group too.
Adriana, if you're there, can you just say hi?
No, it's okay.
Professor Aurora
Aurora.
também.
Sorry,
She's-
we couldn't
she's there.
hear you
Yes. Okay.
Oh,
for
okay.
a second, but we are here. Hello.
Yes. This is Adriana, also part of our project.
The team.
Yes, I'm very glad to be here.
Laura is the teacher that is going with us, and here we have teacher Fatima that is coming with us too.
We'll show you the video now. Can you?
Now, don't you want to talk about first the idea?
Okay, so our project aims to demonstrate how we can levitate an object, and it's a gravity zero simulator. And with magnetic fields, and we want to show you and present to you how can we manipulate a magnetic field in order to present and levitate objects.
This is our prototype for now. We are like 80% done with it.
Yeah, you can show the back of it because it has like all the coding and stuff.
You know, you can see the prototype, but we can see anything.
Go there, Katarina, go.
Sorry.
Okay.
Sorry.
It's not working
It's
now,
not done.
but
We
Oh,
want
yes.
to decorate it and then make it more of like our
more
own
appeal.
Yeah.
So it's
We
like
have
this.
transistors, we have sensors, we have what else?
Arduino, we have
We have
a lot of
coil.
things.
Okay, we have coils, and it all tends to manipulate the currents, magnetic currents. So we have an object here. You can see here. I don't know. You can show.
It's a magnet.
Yeah,
It's a magnet with a kind of bow because
it's a bow,
it's
and
weird.
that's the object that's going to be levitated.
I don't know if we can show you now because it's not 100% working.
Because it's not finished.
Okay, so show the video.
So you should.
We'll show you a video that demonstrates better.
We'll show you the video. And then we can explain a little bit of the coding if you want to.
Okay.
This work aims to demonstrate how to levitate an object attached to a magnet under the effect of a magnetic field created by a coil powered by direct current. A Hall effect sensor is placed near the lower end of the coil that measures the magnetic field of the magnets attached to the object that is going to be levitated. There is a transistor that will work as a switch controlled by Arduino, which will turn on and off the electric current that feeds the coil. If the magnetic field is greater than the value defined by us, then the current that feeds the coil is turned off, which causes the magnets to fall and decrease in the magnetic field measured by the sensor, and then, consequently, the connection of the currents in the coil will attract the magnets, and then so on.
Wow.
Thank you.
So-
Thank you. Thank you.
That was it. The
If you have any questions, we're here to answer you.
Okay. So I have one question. Do you use any amplifier, current amplifier, or only the current sent by Arduino?
Only the current sent by Arduino, I think.
we have a
Battery, and we have a resistance. A resistance?
resistor.
Honestly, yeah. Well, it can show, Kathleen is
It's a-
going to show you.
A resistance to
Yeah.
the
To
current.
make, so you can really know how much.
Oh, no.
amps here.
Hello. Sorry, I can't reach that.
What are you doing? Are you putting in the ceiling?
Wait.
Okay, it's here. Okay, it's here.
Sorry about that.
Here is a resistance.
Oh my God.
Yeah, our
Sorry.
camera is
Okay,
connected.
here
The camera
is a resistance,
Sorry.
and we have batteries
Yeah, we have
Here.
batteries.
here and here.
So the video basically shows the whole process and how it works. But if you have still any question, we can explain it further.
Yeah,
Okay,
so we set a value in the coding, we set a value for the magnets and the magnetic field. If the magnet is going to be attracted, and when it reaches that value, the current stops and then he falls. But then when he falls, the current comes back, turns on, so it is attracted again, so it stays levitating.
Okay, so you have an electromagnet. Yes?
Yeah.
Okay. Did you build the electromagnet or did you buy it?
We
No,
built,
we have the help of
Our
a
teacher.
teacher.
And
Yes.
he built the
the coil.
We bought the cable, the copper
wire.
cable, the wire, and the teacher built it and
Yes.
gave it to us to build the whole prototype.
Yeah.
Okay. So you didn't use the electromagnets that can be brought for Arduino. You build it.
No. Yeah.
So
Yes.
I have this puts me one question. How will you manage for the other teams to have the same? Will they have to build this?
We are going to make
coil?
some
We're gonna bring some.
and bring with us.
Okay. So you will build them and bring with you. Yes?
yes.
Yes.
Okay.
Yes.
Okay.
Yes,
Okay.
because the poles have to be right. So I think it's better for us to build it.
And the coil is like built with 100 meters of wires, so
Yes.
it would be kind of hard to make that.
Okay. How do you make the coil? Do you make it by hand, turning?
No, with
The machine.
Oh, the machine. Okay. A rotating machine. Yes.
Yes,
Yes.
Okay. So how much time do you, just for curiosity, how much time will you take to make one coil?
we don't know actually. Kind of.
Eu não sei quanto é que eu sou.
How much time? How
We
much time?
The
Yeah.
coil, we can't be sure because it was our teacher to make it.
Okay.
It was our teacher that made it and then brought to us to experiment with it and try and build this prototype. So
Okay.
we're not
So-
sure how much time it takes to build a coil.
Okay. So I have a suggestion for you. Is that you show to the other your colleagues
Yes.
in the mobility, you will show to all of them how to make this coil. Okay. I think you should. Anyway, you should record something so that all the others will know how to do it. Okay. You can bring, of
Okay.
course, you should bring coils for everyone, but then you should have something to show them how to build it. because there are some tricks, they take some time, but they should know how to do it. Okay?
Okay.
It can be a video. It can be, but you should show to all them.
Okay,
right?
thank you.
Because it's something
Okay.
that they cannot, it's something they cannot buy. It's something they have to build. And so that takes some problem. I think you should instruct the others how to do it, right? But that's very interesting. Levitation. I want one of these systems. I want one.
€5. I'm kidding.
I will give you 10 euros. Okay. So
We have another one.
So-
We have another one here.
Oh, you have another one. Okay, fine, fine, great.
More than
We actually made three
Three.
prototypes, but one of them is with our teacher that isn't here. So we only have these two that we built them ourselves. And
That we showed in the video.
Yeah. These
Yeah.
were the ones that we built in the video.
Very interesting. I think this project is very interesting.
Thank you.
I must say that I had the idea to build one some years ago, but I had never the time to do it.
Oh, don't worry, we will do it for you.
Okay, great.
I mean, we already did.
And
We'll-
I am lucky because I don't have to go to Rhodes to have one.
You see?
It's true.
Okay, Portuguese team, thank you very much. I don't know if
Thank
anyone of you. Oh, wait. No,
I
Fred,
have a
please.
few questions.
Yes.
If you think that we have the time. Okay. Let me see if I have got it right. So what you have done is that you have created an electromagnet, and then you by through this you can have an object. How do you say it in English?
Levitating.
Levitating. Okay. And have you used some sensors? I mean, what about the coding, the part of the coding? In what way the Arduino is playing a role in this?
Well, the coding in Arduino is like when the magnet
Reaches a value.
reaches the value.
There is a sensor.
In here, yeah, go and show
I'll
her.
just show.
Because the coil has a
There's
sensor.
A
underneath.
sensor here that's electromagnetic field sensor. Sorry, there. And the Arduino, when the sensor reaches a certain value that we determine in the code, it cuts off the current and makes the magnet fall. And when the magnet falls, the electromagnet field
Comes
also
back.
changes and decreases. When it reaches another certain point, Arduino turns the current back on and makes the magnet go up again. This happens like many times per second, like 100 times per second.
So
That's
it's
why,
levitating.
because it just stays like oscillating.
Okay. And I find it quite interesting. It has more of a physics than every project that we have ever done up to here. I like it very much. But let me ask you, how is this connected to the topic that we have living off the earth?
So we wanted to create something that we could experience, such as the zero gravity, because we've never seen zero gravity in something you only see out of the earth. You see when you go to the space, we don't go to the space, but when you are an astronaut and you feel that pressure because you go, how can I say it? You are in zero gravity, and we wanted to try to recreate that type of thing because here in Earth we have gravity. Outside we don't. So that's why we chose this project, honestly. And we thought it was within the topic because living off the earth.
Because like with a zero gravity simulator, is something that also helps here in Earth the astronauts to learn and to study how conditions are off the Earth, out of the Earth. And so we thought that that may help people understand more about living out of the Earth.
Yeah.
And we wanted to use magnetic fields to just
present it and try to make some. And also here we have like a bow to levitate, but we can levitate other objects. We just have to choose a different value, because they have different currents, magnetic currents values. So that's why we wanted to
choose a bow because it's light, and
easier.
It's easier to program the code and to build a coil that can create a magnetic field strong enough to levitate a bow because it's light. But we can literally do that with a literal truck. You just have to have a big enough coil.
Yeah.
This is just a prototype to show a practical use of magnetic fields.
Okay, I suppose that your coding is in C++, not in Tinkercad. Am I correct?
It's in Arduino Uno and it's from blocks. It's programming by blocks.
So you built it in Tinkercad and then you transformed it to C++, yes?
Have you built it in Ardu blocks or on Tinkercad?
Okay, so
What program have you used?
Não sei se foi Tinkercad.
qual era o nome, professora? Mas acho que I think it's the one with blocks, Tinkercad, that then you can transform in language C++. You know that program we use? Blocks.
I cannot see you, Isabel.
Wait, we are trying. Yeah, we are trying. Sorry.
No, you know the program when you use Tinkercad but related to Arduino, that you program in blocks and then you ask for them to translate to language C++.
Yes, otherwise it cannot work. But have you used Tinkercad? This is what I'm asking.
Blocks, and then they ask to pass to language C++. The same?
Yes, but I'm not sure. I'm trying to figure out if Tinkercad has these components. That is why I'm insisting, because I would like to have my students prepared for this. Okay.
Mas não foi em blocos.
Maybe I don't. Maybe they have simulated the electromagnet in Tinkercad and then they adapted to the one they have built. I don't know. I'm just saying.
I have to search for because as the students have said, they have used a sensor for magnetic field. I should see where exactly this is in a Tinkercad and how it is.
I think let me ask something. Is this sensor the Hall effect sensor?
No. For Tinkercad, it's not something like this.
Wait, can I ask Adriana? Adriana, are you there? Adriana, because she's the
I am teacher.
She has problems with
the picture.
The picture of what?
The coding. The coding.
I don't think I do have a picture of the coding. I made a video, just a small video, because it was a very small part of our project.
Okay. Okay, so they have here, it's in Portuguese. I don't know if you can see.
No, can't see nothing. We see something.
Yeah. Muita luz, but wait. So it's a gente vai.
Wait.
We see something. There are blocks. Yes.
Yeah.
but we cannot
I think
understand
it
what
is are the
written.
blocks.
Yeah,
I think.
it is blocks, definitely. It's just that if it is not in Tinkercad and it is in Art Blocks, then we should, the reason why I'm asking is because I will need to have the computers prepared. So if you have used Art Blocks, then I should have installed the Art Blocks into the computers. I cannot, this is not possible for me to see.
You cannot see that, but it's in Tinkercad. Oops.
If it is in Tinkercad, it is okay for me. It is okay.
Yes, it is
The only
Tinkercad.
reason.
Can you see it now?
Tinkercad, yes, we can see.
Is it Tinkercad?
Okay.
Okay, so
It's
levitation.
okay. This is the only reason why I'm asking, because if we needed to use another program, I should have it installed in the computers. Okay.
Okay.
Okay, can you also searchable?
So, team, I had one question, but maybe you have answered, because I thought that for measuring the magnetic field, you have used a Hall effect sensor, but you are saying that it is not a Hall effect sensor. Am I correct?
They don't know. Can you say in Portuguese? Because they don't know what holy, whatever, professor.
É um sensor de efeito Hall.
Sim, yes.
Yes.
So it's a,
yes, the
it's
teachers.
Usually it's a Hall effect sensor that we use when we want to measure the magnetic field.
Yes.
Okay.
Yes.
Yes, I have
It is.
also the names here.
So it's a Hall effect sensor. Okay. So with this Hall effect sensor, the second question I have is that you can change the position of the magnet, right?
Yeah. Yes, we just have to change the values in the code.
Yeah, we have a set point, and we need to choose the set point.
Like,
and
I don't know if you can see.
Not the value, the position.
To have the magnet here or whatever.
So
like,
you just say what is the value of the magnetic field measured by the Hall effect, and then you can change the position of the magnet in relation to the coil. Yeah.
yes.
Yeah.
Is it true? Yes.
Yes, that's it.
Okay, that's fine.
But it only stays in one place. I think the magnet only stays like here.
At a fixed
Yeah,
height.
because it's the set point, and it's reaching over and under. It's over and under, so it stays in just one place. I don't know if that's what
And
you
then
are
it starts oscillating a bit.
Yes.
Current is always increasing, decreasing, increasing, decreasing,
Yeah.
increasing, decreasing.
Yes. That's
Okay, that's it. That's a fine thing. You know, magnetic fields are very important when astronauts go in missions, but they are also important on Earth because especially levitating, because the friction is diminished when things are levitating. So it can be either used on space, and I think that you have some misconception about this in space, because if you have in space a magnetic field, then immediately it attracts the objects, magnetic objects, and you cannot stop them. You can have this balance on Earth, but you cannot have this levitation on space. But anyway, magnetic fields are very important either on Earth, either in space, especially, for example, for reflecting the radiation. Yeah, the ionic particles. They can be reflected, and they must be reflected. Otherwise, they can go to our body, the astronaut's body, and make some injuries. So that's one of the problem of the space missions, is the ionic particles that are emitted by the sun.
Yes.
Thank you.
Okay, it's great. I like. So, Hara, do you have some other questions? Or Petronia?
Not for the time being, but
Thank you.
Okay, thank you. So, at last, we go to no, before we go to Romania. Yes, Petronia?
Of course, not a
Romanian team?
problem.
I wanted that my team will introduce themselves. One student is missing because he was at the beginning but must leave our meeting, unfortunately. So, David?
Hello. My name is Codinanzo David, and I'm a student of Edmond Nicolau, and I'm gonna let now the others of the team present themselves.
Stefanel?
Hello, my name is Stefan. Stefanel, but you can call me Stefan. I prefer that. I'm also I'm also a student at the Technical College Edmond Nicolau, and I'm really excited to meet y'all.
Juana?
Hello, my name is Ana, and I'm 15 years old. I live in Romania. I student Edmond Nicolau High School. I am glad to soon I will meet you all.
Okay, thank you. And the last one?
Hi, my name is Bajana Romina. I'm from Edmond Nicolau Technical College. I'm 16 and I feel excited to be here in this Zoom meeting.
Sorry, because Mihna has no video because he is on his phone without resources, many resources.
I'm sorry, I'm trying to fix next time.
I know, we know, of course. If it is possible, we will start our presentation with very few words. It's what you told us before. It is a difference between the two concepts about living off the earth. So we try to find the solution to put together all the two conception about living of the earth. So now I will introduce a video, short video, and after that I will leave the students to present the rest. Just a moment. I hope that you all have sound too.
Hey everyone! Ever wondered how astronauts stay safe millions of miles away from Earth?
Do you have sound?
Today I'm diving into the fascinating world of the astronaut vital signs monitoring system. So let's break it down. This system is like Iron Man's suit, but for astronauts. It's a wearable device that tracks vital signs in real time and alerts them if something's off. Imagine having your own personal medic right on your chest. First up, the key components. At the heart of this system, we've got the Arduino Uno. It's the main microcontroller that processes all the data. Then there's the pulse oximeter sensor, which checks heart rate and blood oxygen levels. If your oxygen drops below 90%, bam! The buzzer sounds and the LED starts blinking. Pretty cool, right? Next, the body temperature sensor. It keeps tabs on your body heat. And of course, the accelerometer and gyroscope, which track your movements and orientation. It's like having a tiny gym trainer, making sure you're not floating upside down. All this data is displayed on an LCD screen in real time, and if anything goes wrong, the buzzer and LED alerts make sure you're the first to know. Now let's talk about putting it all together. First, design your system. Plan out where each component will go for optimal wearability. Then move on to hardware assembly. Connect the sensors, display, buzzer, and LED to the Arduino. Power it all up with a battery pack. Make sure you follow the wiring steps carefully to avoid any mishaps. Next comes the software. You'll need to install some libraries and write code to read data from the sensors, display it and trigger alerts. It's a bit of a challenge, but hey, you're basically building a mini computer. Testing and calibration are crucial. Compare the sensor readings with a commercial health monitor to ensure accuracy. Adjust calibration parameters in the code if needed. Simulate abnormal conditions to check if the alerts work properly. Finally, deploy and demonstrate your system. Wear it, move around, and watch the data in real time. Discuss potential improvements like wireless data transmission and SD card logging for long-term analysis. This project doesn't just make you feel like a NASA engineer. It teaches you valuable skills like coding, sensor integration, and problem solving. Plus, it's a great way to understand the importance of astronaut health monitoring. And remember, this tech isn't just for space. It can be adapted for firefighters, miners, paramedics, or even patients with chronic illnesses. The possibilities are endless, so what are you waiting for? Dive into this project and explore the universe of astronaut safety. Until next time, stay curious and keep exploring.
So this was our movie, and David.
Yes, I will now present our project. So we've been thinking about creating a circuit that checks the vital parameters of a person in real time. The system integrates a pulse oximeter sensor, a body temperature sensor, and an accelerometer and gyroscope to collect and display psychological data on an LCD screen. Our dream is to provide the real-world application of Arduino and sensor technology, helping students develop hands-on skills and appreciation for astronaut health monitoring. And now to my friend Stefan.
Yeah, I will, 1 second, I will just share my screen for David to present over here.
Yes, we're now gonna comment our working progress on Tinkercad. This is the second one.
1 second, let me, yeah, here.
Okay, on the first one, we started working on this project, which we have a potentiometer, which simulates the pulse of a human being, and a temperature sensor that simulates the temperature, and 4 LED lights that are gonna blink when the temperature is too low or the pulse is too high. And we have an LCD screen that is gonna tell if our pulse is okay or it's too high. So we can now start the simulation and see. We're gonna put firstly the temperature to 36, which is the normal temperature for a human being. And it's gonna say we are okay. And if we put our pulse and temperature low, it's gonna start saying that our pulse is low and our temperature is too low.
And
same
also
thing
there's a sound. If our temperature and our pulse is too low, there is a sound. And if it is too high, also there's another sound.
Different sounds.
Yeah, different sounds. I hope you can hear that.
Yes.
And now for the other project.
Not another project, another phase.
Yes, the other part.
Yes. Please, David.
I thought Stefan would do.
Yeah, I will present this. This is a ultrasonic distance sensor. It's pretty similar to something we use in cars. You may know when you back up into parking spaces, there's a sensor that beeps when you're getting close to a car. This is pretty similar to that. So I will just start the simulation. Actually, let me break down the components over here. We have the ultrasonic distance sensor over here. Then we have a few LEDs that basically tell us the distance. The green LED is on from 200 centimeters to 100 centimeters. Actually, it's on from 200 centimeters. The yellow one is on from 100 centimeters, and the red one it's from 50 centimeters. So when you're really close, they'll all light up. And also there's a buzzer that will display different sounds on according to how far you are from the according from how far the object is from the sensor. And also there's our screen which will display our distance, and here we have the simulation. Okay, so here we have 226 centimeters, so nothing is buzzing, nothing is lit up. And if we go down slowly, we should have the green LED light up because it's less than 200 centimeters. Then more on down, we have the yellow LED, and then on 50, we have the red LED, and the buzzer will start to display a sound. And slowly, while we're getting our distance closer, the sound will change.
Okay.
And here you can see on the display that it tells us the distance and the time that it took and the time of the simulation. And that's basically it.
Okay, the next one. Do we have another one?
No, we don't.
Okay, so I will introduce just a few words, and after that I will ask you to present more. We use this simulation on Tinkercad using based on a potentiometer that simulates or allow us to change some parameters like the parameters that we will collect from sensors. So for Tinkercad, it is basically, and for real prototype, we will use some sensors that we will have from today. Only today they arrive to us, and we hope that we will make a presentation. We'll make a prototype using real sensors and real situations, but on the same ideas.
So for the pulse, you have a heartbreak, yes? Heartbreak sensor.
Yes, also, and
heartbeat, sorry, heartbeat sensor.
Heartbeats, yes, and of course, we hope to manage to include.
It's great. It's great. Yeah.
Gases. I forgot the term in English. To determine the saturation of oxygen.
O2. Yeah.
Yes. And because it is possible that a lot of accident happens, so we will use an accelerometer and gyroscope to determine if a person fall down, it's lying on the soil, on the earth, or on the soil, or if short impact arrive to the person.
Okay. That's great. Really?
Stefan?
Yes.
Close the share screen.
Oh, sorry.
Okay.
Okay.
Will you build a bionic suit for this?
We'll try. We have 1 month from today. Today, the sensor arrives. Almost all today. Tomorrow, I hope that the last one will arrive, and we hope that in 1 month we will be able to include at least some of these sensors to our suites.
Well, this is a great project. Congratulations for you all. It's great, superb, really. David and Stefan, how old are you?
Oh, I'm 16.
Oh,
yeah, we're both 16.
Okay, okay. No, really, it's great. There's one question I have to put. I would like to put. When you say that this buzzer sounds, do you mean it changes? Sorry, do you mean intensity, not frequency? Yes, or is it the frequency that changes?
We changed the tone to it.
You changed
the tone,
not the frequency.
You changed the frequency. Yes.
Yes.
Okay, not the intensity. It's in frequency. So it becomes higher frequency when it becomes closer. Yes.
Yes. Exactly.
Okay. So, great. I think it's a very interesting project to build a bionic man, yeah, or a bionic suit.
Bionic suit.
Bionic suit. Okay, I find some similarities in some points with the Latvian project. Yes.
Yes.
This proximity sensor to detect if an object is closer to the astronaut. In the case of Latvian, it's closer to the rocket. Yes. So I find some similarities, but I'm quite sure you will discuss this in the mobility, and
of course
you will benefit from both projects. Right. So Any other questions to your projects, to your project or the Romanian project? Yes? No? Then the last one, the Greek one.
Hey.
Ara, where are you? Oh, you're there.
Hello, everyone. Most of my students were tuned in today so that everyone could see each other. Now, let me introduce you to the team that is with us for the project at Rose. We have a little technical problems with some of them. Okay, Eleftheria, will you start? Eleftheria Bibari.
Yes.
Okay.
We are the Greek team. It's nice that we're last as the host team. I'm Eleftheria. You can call me Elfi for short. And I'm 16 years old. Andriana has a problem with her microphone, but she can like wave at you. Then Konstantinos.
Hello, my name is Konstantinos. I'm 16 years old. Very nice to meet you. Can't wait for you to come.
Then Victoria.
Hello, my name is Victoria and I'm 17 years old.
And Kostas.
Who has a problem with his video?
With his video.
With his
Hello,
camera,
I'm
actually.
Tesla. I'm 16 years old and I can't wait to see you all in person.
We are all excited to see you and host you and have a great time.
Okay. Now, let me share the video. Just a minute. Share. Okay. Suppose this one. Okay, share sound. Optimize what would you say? Let's see. Okay. Is it on?
Yes, it is.
Hello, friends. Ever wanted to grow plants at home without the hassle? We thought as a team that living of the earth means to create a sustainable, efficient, and convenient food production system. Today, I'm going to show you how to build a smart greenhouse to grow plants for food using a simple device called Arduino. Let's get started. First, you'll need an Arduino board, a soil moisture sensor, a light sensor, a water pump, and a small motor. If you're new to Arduino, don't worry. I'll guide you through it step by step. Start by connecting the soil moisture sensor to the Arduino. This sensor will check if the soil is dry. When the soil is dry, the sensor will tell the water pump to water your plant. But we only want to water the plant when the sunlight is low. So connect the light sensor to the Arduino. This will measure how bright it is. If it's too bright, the system will wait to water the plant to avoid burning it. Next, let's add a temperature sensor to check how hot it is inside the greenhouse. When it gets too hot, the motor will open a window to let fresh air in, keeping your plant cool and happy. You'll need to write a simple code to make all these parts work together. First, we use Tinkercad to make a simulation. We need to see how everything works together. Once everything's set up, place your plant inside the greenhouse and watch the magic happen. Your new smart greenhouse is now ready to keep your plant thriving effortlessly. Cheers and happy gardening.
So the main, I'll tell you what we thought the meaning of living of the earth means. Well, as a team, we thought that living of the earth means using the natural resources that earth provides us with to satisfy our basic needs. It could mean that we live out of the earth and we need to have conditions in space to be able to have plants, which are the main source of life, so we can survive. The best and simplest way to portray that into an application would be to make a greenhouse that helps to grow plants efficiently and with sustainability. Konstantinos will tell you more about the project.
We, just like Eleftheria said, how the idea came. I would like to tell you what we're going to use, the components, and how we're going to use them. So we are going to have an LCD screen, which every 10 seconds will give us different information. We will also have a DC motor that we will use in Tinkercad because we would like to use a water pump, but because Tinkercad does not have a water pump, we will be using a DC motor to represent the water pump. We will also be using a temperature sensor to tell us and measure the temperature inside the greenhouse. We will also be using a photoresistor to tell us if it's day or night and give us that information. We also have a servo for the windows, which will be using the temperature sensor to determine if it's too hot, because if it's too hot, we have to open the window. And we can also use 3 LEDs, red, green, and blue LEDs, to indicate the temperature. The red can indicate
Bad connection, we cannot hear you, Constantino.
the blue. I'd like to add some extra things that we're still deciding on. We'd like
Constantino,
to use
are you listening to me? Can you hear me? Can you please say again about the LEDs? Because we didn't hear you.
Oh, sorry. We have 3 LEDs, which indicate the temperature. We have a red LED, which says that it's too hot, a green LED showing it's just right, and a blue LED, which means it's cold in the greenhouse. Did everyone hear me?
Yes. Okay.
We would like to add some extra things that that we're still deciding on, because we're going to be using the Arduino R4, and because it also has Wi-Fi capabilities, we are deciding on connecting it with our phone, so we can go on an application and tap on off depending on what we want to do. I don't know, open the servo for the window and different automations. We are also deciding to put a solar panel instead of it being plugged in, or a battery, so it always has power. We initially designed it in Tinkercad, and we still are, but because Tinkercad doesn't have all the components we need, we just use different components. For example, the water pump, we're going to use the DC because it has the same negative and positive poles. We are going to be using the Arduino IDE to write the code in C++ because we have some basic knowledge on that, but not enough, and we use the help of AI to learn and continue using C++. Yeah, that's it. That's our project.
This project looks very similar to what the Romanian team has brought to Istanbul, but the students had already decided on it before the mobility to Istanbul.
It's not any problem because there are many solutions for the same problem.
Okay.
It's true. Well, guys, this is a great project. I like it very much. Build a greenhouse. And you know, this the study of how to build plants is not only a problem on the Earth, but also a study that has a long time, that has been a long time studied by astronauts to build plants to cultivate plants in space. It has a lot of problems, of course, but it has been an object of studying for many, many years. Of course, that in space, we don't have the problem of the sun. Light is controlled, so they don't need to have this control of too much heating, and only the problem was of the water in soil. But on Earth, it is necessary. I have one question. You said, Konstantinos, that your water pump was, or there is no water pump on Tinkercad, so you replaced it by a small motor. Yes. Instead of water tank, you have a small. Okay. Did you already tried your setup with the water pump?
No, because we only have one, and we're kind of skeptical to use it because it might break. It might.
Okay.
We're at the beginning. We're at the beginning. We are just now setting the.
Okay. So have you ordered already this water pump?
Well, we have one.
We have it. Yes.
We have one. If it works, we will order 4 more for everyone.
Sure. Okay. Okay. Now, you said that there is, I'm talking to Konstantinos again, yes, but any other of the group other one of the group can answer. You said you had a blue LED, and let me see, the blue LED is when it is too cold.
Yes.
So what happens if it is too cold? Do you have a heater or something? Imagine
we haven't thought about if it's too cold, because that's the point of a greenhouse, to use the sun to capture the heat inside the area that the greenhouse is. And we haven't thought about a cold, if it's too cold.
Yeah, but if you have it, there is a buzzer that's alerts that the greenhouse is too cold.
Yes.
Then maybe you should think about what to do,
Well, we thought that's why we put the LEDs. The cold one, I mean, it's not an automatic reaction, but when we see the blue LED, we can understand that it's too cold, and we can, use other things to warm the greenhouse.
Okay.
Because there's not like a heater in our Tinkercad.
Okay, of course. But if you have the LED, then maybe you can think about a solution, right? Otherwise, we will go there, the buzzer buzzes, and we go there and say, oh, it's cold. Then you start
blow on it until it's warm.
With the plants, it doesn't work. So just think about that. Okay, maybe you will not be able to do anything, or do you have anything to do? Maybe just thinking, oh, okay, I should have a heater. I should put a heater to heat a bit the greenhouse. But anyway, you have this warning, but you should think about a solution.
Yes,
even if it is not automatic. Okay. So great. We are almost at 4 o'clock in Portugal. I know that Zeynep and the Turkish team has to leave, but if anyone else has, what is going on with the Maya group? They are putting some flowers in the screen or what? Okay, so if there is no other, oh yes, rockets now.
Rockets.
I can see Maya, I can see rockets. Okay, so if there is no other person who wants to say something else, oh, maybe I should ask, does anyone want to say something else?
Well, I would like to say something. Please, if there are any diet restrictions or allergies with students, please write them down at the data, because I don't have any data, and I need to know for sure. If there is some student that has problem with pets, dogs or cats, we should know. I have already, my students as probably have already text your students because I have given them the names. But if we have such kind of problems, we can still make some changes. Okay.
Thank you, Hannah.
Okay. So, congratulations for you all. Your projects are very interesting, are great. I wish I could be in Rhodes to see them all, but I
We
can't.
wish you were here.
Yeah, me too. But I will be in
Yes.
November.
Yeah.
Will be in November. I hope. Okay, so we will finish here. Thank you for coming. Hashem, thank you for sharing your ideas and your projects. I wish you 1 month of hard work.
Yes,
And
sure.
then, yeah.
Thank you. Sure.
And I hope everything will be okay in Rhodes and we will profit a lot. Okay.
Thank you very much.
Thank you for all.
Thank you. Thank you for
I'm
your
looking
leadership. Thank
forward
you so
to
much.
seeing you all. Bye
Hope
bye.
to see you soon. Bye bye.
Yeah, thank you.
Goodbye. Thank you. Bye bye.
Bye bye. Bye bye.
Bye bye.
Bye.
Mm.